Welcome to Highline Excel 2016 video number 5. Hey, if you want to download this Excel workbook, Business 218 video number 5, or you want to download the PDF file, click on the link below the video. And these are some very helpful notes about array formulas. Now let's jump over to our Excel workbook. Now I actually want to go back to the sheet video to reminder, because we want to start off by talking about the difference between aggregate calculation and array calculation. We already went through two examples back in video number 2 when we were reviewing different formula types. Now an aggregate calculation is simple. We're taking a bunch of different values, performing the adding calculation, and delivering a single answer. That's the hallmark of aggregate. Get a bunch of numbers, get a single answer. Now, another synonym for a bunch of numbers or a bunch of things, or more technically, anytime you have two or more things, you can refer to it as an array. Now, this is not an array formula. We are operating or calculating on an array of answers. But when the formula evaluates, it gives you a single answer. And that is distinguished from an array formula. Now, this formula, if I hit F2, we saw this in video number 2. The final answer here is a single answer. It's 791, because our goal was to add the top 3 bowling scores for Tom. But if we F2, the inside part, sitting in the number 1 argument of sum, that involves an array operation. And here's how it works. That k argument is expecting a single number, like 1, which means large would look through here and find the first biggest. Or we could give the k argument a 2, for example, and it would go through and it would deliver the second biggest. But the fact that we gave it 1, 2, 3 items, we gave it an array of items, that instructs the large function to deliver 3 items. And that is the hallmark of an array calculation in an array formula. When we evaluate this or calculate this with the F9 key, the fact that it did not deliver a single answer, but it delivered an array of answers, that means we're dealing with an array formula. Control Z. But the large did do an array operation, but then we put large inside of an aggregate function, and it went ahead and calculated the final answer, which is 791. Now let's go over to the sheet Array Formulas. Now let's start off by defining what an array formula is. We're going to define it based on what it does and what it delivers. What does it do? It makes some calculation on an array of items rather than a single item. In our large example, the array of items was the 1, 2, 3, rather than a single item like 1 or 2. The second part to the definition of an array formula is what it delivers. The calculation results in an array of answers. For the large, it spit out simultaneously 3 answers: the first largest, second largest, and third largest. And we're going to call that array of answers the resultant array. Number 3, the resultant array can be used inside a larger formula, or it can be the final answer. Our large example we just did, of course, our resultant array went into the sum function, which was the larger formula. We will see examples in this video where we actually deliver simultaneously the resultant array, the final answer, into the spreadsheet, into the cells. Finally, number 4, array formulas require the special keystroke, Control-Shift-Enter, in order to calculate correctly, except in these situations. If we're using one of these 5 functions, and for us we'll use sum, product, and aggregate. If we're using these functions and we're making array formulas, we do not have to use the special keystroke. Also, if the arrays are array constants, then you don't have to use Control-Shift-Enter. Now I want to go back over to our sheet and look at this definition now that we know it, and look at the array formula for our bowling example we did back in video number 2. I'm going to hit F2 here. Now the array operation is the fact that we gave 1, 2, 3. Simultaneously, we gave the k argument 3 numbers. That forced the large function, when it made the array calculation, to deliver a resultant array. So when I hit F9, that's the resultant array. And in our case, we didn't deliver the 3 values into the spreadsheet cells. We kept it inside of a larger formula, and our larger formula was the sum function. Now I'm going to Control-Z. Finally, we didn't have to use Control-Shift-Enter, the special keystroke, because our array was an array constant. All right, I'm going to click Escape. Let's go back over to the sheet because we're going to see a bunch of amazing examples. Now, first, before we do anything, here's our budget example we've done a number of times in this class. Here's a formula. Oh, yeah, we're calculating cost of goods sold based on our expense ratio for the month of January. We copied this formula down and over. Now, before we make our second array formula down here, I want to remind ourselves what a non-array formula looks like. So I'm going to calculate cost of goods sold for January. In this cell, equal sign, hey, there's revenue, but notice it's a single cell times, and there's our cost of goods sold expense ratio. A single item with a math operator, and there's another single item. I don't see any arrays here. So when I hit Enter, it calculates perfectly as a non-array formula. Now, if we look at the total expense formula up here, F2, notice the sum function is adding 1, 2, 3, 4 cells. Now, most of the time in budgeting, we want to see those. But sometimes you don't want to see all of the individual detail. You just want the final number. So is there a way in this cell right here to not use up 4 cells, but in a single cell calculate all 4 expenses? You bet. And this is actually the number one reason that we create array formulas. We want to make a bunch of intermediate calculations or steps that we normally do in the cells, and we want to do them all in a single cell. All right, so you ready? Here's our second array formula. Equal sign, there is revenue for January, a single cell, times, that's a math operator. That will be our operation. And watch this. I'm going to highlight an entire range or array of values. Now, anytime you have some operator and an array of values, you are making an array formula. And because we have B4 times the whole range, B4 will actually be taken and it will multiply times 46. And it will be multiplied times 19 and 15 and 4. This array operation will deliver 4 answers. Now, let's go ahead and highlight this and F9 to see this. And there's our resultant array. That is the array of items or array of answers that that array calculation delivers. Now notice, it's not rounded, but 30422, boom. 12,756, boom. 10,110, 2,643. All 4 values were calculated in a single cell. Now I'm going to Control-Z, because remember, up here we have the round function. We need to round these, so no problem. I can wrap the round function around an array calculation, tab, in the number argument. If I evaluate this, notice that's the resultant array. That's the first array operation we make. But now that a resultant array will be dumped into round. Control-Z. Round is not an aggregate function like sum, so it's definitely not going to like add them. It's just going to round all 4 numbers. Comma, 2 because we're rounding to the penny, close parentheses. And if you highlight this and evaluate it with F9, you bet round will round to the penny all 4 values. And notice 1, 2, 3, 4 values, all calculated in a single cell, just like the values up here in the individual cells. but now we're in a single cell. A more compact Excel solution. Control Z. Now, what's our ultimate goal? We need to add them. Now, we're going to use the sum function. And I'm going to come to the end and close parentheses. Now, when you're ready to enter your formula into the cell, you have to ask yourself, does this array formula require the special keystroke Control-Shift-Enter? So we're going to look up here. If it is one of these 5 functions right here, then we don't have to use Control-Shift-Enter. So sum function, I don't see in this list. And the second consideration is, are the arrays array constants? No, they're not. So this formula requires the special keystroke Control-Shift-Enter. Now I'm going to hold Control-Shift and then Enter. But wait a second. I want to show you what happens if you don't use the right keystroke for an array formula. I'm going to hit Enter. Let's just say I forgot to do Control-Shift-Enter. That value error is telling you, hey, you forgot to use the special keystroke Control-Shift-Enter. So I'm going to F2. And now, you ready? Control-Shift and Enter. And boom, just like that, we get exactly the same answer, except for down here, we did not have to use 4 individual cells to get to our final answer. All 4 calculations are done in a single cell. Now, this is an array formula, and we used Control-Shift-Enter. So as soon as you Control-Shift-Enter, you have to look up to the formula bar to verify that the curly brackets were entered. Those curly brackets are Excel telling you that it understood that you wanted to do an array formula. Now, let me run through that again because this is important. I put this into edit mode. When I do Control-Shift-Enter, that's me telling Excel that this is an array formula. Those curly brackets are Excel telling you it understood and calculated this as an array formula. Now, those curly brackets cannot be typed in. They're only put in automatically when you use Control-Shift-Enter. So the only real way to verify if your formula calculated as an array formula, if that keyboard is required, is to look up into the formula bar and check for those curly brackets. Now, the reason that checking for those curly brackets is so important is because, yes, if we forget to do Control-Shift-Enter and I hit Enter, that value error reminds me. So there's this reminder. But watch what happens if instead of the array formula being below or above the array of values in our formula, if the formula happens to be next to the array of values, and notice when I put it in edit mode, the array formula is next to the array of values. What does it do? It calculates through something called implicit intersection the actual individual value as if it was an individual cell. If I move this down here, look at that. Because I'm next to 15%, it gives me just that single answer. That's not what we want. But notice, if I, in this cell right here, just hit Enter, I might for a second be tricked, thinking that I got an answer. But if I entered the formula without Control-Shift-Enter, by always verifying up here that the curly brackets are there, I'll never get into trouble. They're not there. That tells me I forgot to use Control-Shift-Enter. So now, F2, if I use Control-Shift-Enter, it doesn't matter if the array formula is next to the array, below, or above. So you ready? Control-Shift and Enter. I am verifying. I see the curly brackets, so I know that this calculated correctly. Now I'm going to move this back here. Now, I actually forgot one thing. F2, I'm going to manually highlight that range and hit F4. Now, what if I edited it, which I just did here, and I forgot to do Control-Shift-Enter? Well, of course, it's not going to calculate. So even if you edit it many, many times, you have to remember every time Control-Shift and Enter. And look up to the formula bar. I see those curly brackets. Boom. Now I can copy this over to the side. I go to the last cell, F2, and sure enough, it's looking good. I got the right cell references. Now, if I forget to hit Enter here, I get the value error, right? So if you put it in edit mode, be sure to Control-Shift-Enter. If the formula has already been entered, then, of course, if you hit F2 and check to verify if the cell references are in the right place, you can use Escape to revert back to what was in the cell before you put the cell in edit mode. So I'm going to hit escape. Now, we got to talk about one of the more amazing built-in functions in Excel called sum product. Because wouldn't it be nice if we didn't always have to remember Control-Shift-Enter? Well, anytime you have array calculations that you need to add, don't use sum, use sum product. Now, sum product is specifically programmed to perform the array calculations and then add. Now, let's come down here and do the same exact calculation again. I'm going to zoom in just a little bit. Equals, and here's our January revenue right here, times our 4 expense ratios, and I need to lock it with the F4 key. If I evaluate this, hey, there's our unrounded 4 expenses, so Control-Z. I need to take that resultant array and put it inside of round. I come to the end, round it to the penny using a 2, close parentheses. If I F9, I can see clearly the resultant array has 1, 2, 3, 4 expenses. My goal is to add them, Control-Z. So instead of putting them inside of the sum function, I'm going to put it inside of sum product. Now, normally, sum product takes array 1 times array 2 times array 3 and then adds them. And we'll see a great example in just a moment of how to use multiple arrays. But anytime you have a series of array calculations that you need to add, you just throw it into array 1 inside of sum product, close parentheses, and watch this. I hit enter. Totally calculates perfect. And you look up to the formula bar, there are no curly brackets. All right, let's copy it to the side. Go to the last cell, F2, and sure enough, we have exactly the right cell references. Escape. Now, in this situation, we needed to calculate January, February, and March, the actual total expenses. But what if our goal was not the individual March, but we needed the overall total? Well, if I hit F2 here, well, wait a second. This is adding up each one of these. So that means if I somehow, in this cell down here, could make all of these calculations in a single cell, then I could accomplish my goal. It's no problem. Let's notice what we had to do to get this rectangular range of expenses. I had to take, in essence, all of the months times all of the expense ratios. If in an array formula, I simply take this range times this range here, that means 4 cells in 4 different rows times 3 cells in 3 different columns. If I multiply them, I would get exactly this rectangular range. So let's try our next array formula. Cell B30. Our goal is to calculate total overall expense in a single cell. Now notice, there's our expense ratios, and there are our revenues for each month. Let's just try this. Equals, and I'm going to take, hey, revenue for January to March in 1, 2, 3 columns. And I'm going to multiply times expense ratios in 1, 2, 3, 4 different rows. When I hit F9 to evaluate, you've got to be kidding. If we look at this resultant array, every single one of these numbers, including this last one of 2,624, are exactly the numbers in this rectangular range, all in a single cell. Now, we need to round them, so Control-Z. I can simply wrap round around that resultant array, comma 2, close parentheses. And now when I evaluate this, sure enough, every single one of these numbers is exactly the rectangular range. Control-Z, I need to add. I'm not using sum. I know that sum product is the perfect function for making an array calculation, then adding, all without having to do Control-Shift-Enter. Close parentheses, and when I hit Enter, there is the total overall expenses in a single cell. If we look up here, sure enough, we got the same exact answer. Now remember, the goal of a single cell formula is when we need the total overall number, but we don't need any of the individual calculations. That is quite amazing. Example number 3. Our goal is to calculate overall net income in a single cell. Now up here in our complete table, there's the calculation for net income. It's, of course, total revenue minus total expenses. Well, we already just calculated our total expenses. So I'm going to cheat down here. I'm actually going to copy this. Highlight, Control-C, Escape. And now that part I can subtract from total revenue. Well, total revenue is easy. Alt equals, I highlight 3 cells. This is not an array formula. This is just an aggregate calculation, but that'll calculate total revenue. Minus Control-V. There's our single cell formula for total expenses. There we go. When I hit Enter, single cell formula for net income. Exactly the same as we got up here. So the benefit of array formulas, if you're after a certain calculation that has many intermediate steps, but you don't need to see all of the intermediate steps, you just want the final answer, array formulas are amazing. Now, in these first 3 examples of array formulas, we used the sum product function, but we only used the first array. So in our next example, we actually want to see how to use these other arrays. Not only that, but notice we did multiplying, and the sizes or dimensions of the arrays were different. This is 1 row by 3 columns. This is 4 rows by 1 column. Not only that, but this formula over here, this wasn't even 2 arrays. It was just a single cell times 4 items in 4 different rows. So in our next example, we're going to see how to use sum product to multiply arrays when they are the same dimension. Now, our goal is to calculate total bank deposit. So in this cell here, we need our total deposit. And in our template, we have the denominations 1, 5, 10, 20, and 100. And every day we have a different number of each bill. Today we have 16 ones, 5 fives, 22 tens, 43 20s, and 5 100s. Now, if we didn't know how to do array formulas or use sum products, here's what we'd have to do. We'd say $1 times the number we have, 16, plus 5 times 5, plus $10 bill times 22, plus $20 bill times 43, plus 100 times 5. Now notice, we have 2 different types of math operation. We're either multiplying or adding. Now, another way to look at this is this, and I'm going to hit Enter. We have a 1 row by 5 column array times another 1 row by 5 column array that we need to multiply each one of the corresponding elements and then add them. Notice multiplying is product, and then adding is sum. So instead of doing this big, huge, long formula, we simply use sum product. Array 1, array 2, we can put as many arrays as long as they have the same dimensions. And sum product will first multiply and then add. So array 1, 1 row by 5 columns, comma. Array 2, 1 row by 5 columns. Close parentheses, and there we get exactly the same answer. Instead of doing this long formula, we want to use sum product. Now, it's very important that we have the same size arrays here. If we accidentally try to do sum product, array 1, this will be a 1 by 4, so we forget a cell, right? Comma, and then we do a 1 by 5. Close parentheses, it's going to give us an error. Not only that, but in our previous example, notice we were multiplying arrays that were not the same size. If you tried to do this inside of sum product, you'd get that same value error. But wait a second. This is inside of sum product. Yes, but when we're multiplying, we're doing a direct math operator on 2 different sized arrays. If we have 4 numbers in 4 different rows times 3 numbers in 3 different columns, when we do this direct multiplying with the multiplication symbol, it'll give us that rectangular range. In this formula, we're just using the array argument to avoid Control-Shift-Enter and to get the sum part to add. So when I hit Enter, that works fine. When we're using The arrays, those dimensions have to be the same. And by the way, they can be arrays in two different rows with the same number of columns. It could be actually in two different columns with the same number of rows. Or it could be a rectangular range. In all three situations, the two arrays or multiple arrays have to be the same dimensions. All right, enter. Now, we want to move on and talk about function argument array operations. Example number 5. Well, we've already done function argument array operations, and we've done it in the k argument of the large function. We want to see here 1, 2, and 3 examples of how to use a function argument array operation. Now, here's a similar situation to our bowling example. We just need to add the 3 biggest sales. Well, we can use the large function. Array just means, hey, where are all the numbers, comma, and that k argument. If I were to put a 3 here, a single number, then large spits out a single answer. But that's not what I want. I want the 3 biggest. So I'm going to hard code the numbers, open curly bracket, 1, comma 2, comma 3, close curly bracket. So by putting an array of numbers, 1 through 3, that instructs large to spit out 3 answers. Now I'm going to close parentheses, and if we F9 this, you can see, sure enough, by putting an array of items into K, it spits out the 3 biggest. Now Control Z. Now why is this called a function argument array operation? Well, there's the array, and it's sitting in the function argument K. So the array part is the array constant. The function argument is K. And the operation is when large spits out the 3 answers. All right, now we need to add this. So we have a choice. We can use the sum function or the sum product. Well, guess what? This is an array constant. And we know from our 2 rules for whether or not we have to use Control-Shift-Enter, we have to look at the function. And if it's an array constant, we don't have to use Control-Shift-Enter. Now, we will see an exception to that later when we're entering array formulas into multiple cells simultaneously. But for the single cell, that array constant does not require Control-Shift-Enter. So we can simply use the sum function to add. Now, of course, it would work with sum product also, but I'm going to use sum here. When I hit enter, there's our 3 biggest sales. Now, this example here, we need to add the 3 fastest. In many sporting events, you have some cumulative total. In our case, it's going to be the 3 smallest values, and those added together will be your final score. So we're not going to use the large function. We're going to use the small function. It's the same as large. We give it the values we want the small to look through in the array argument. The k, I want to make a function argument array operation to get the 3 smallest values. So I put my array constant. F9 will show us, sure enough, it got the 3 fastest or 3 smallest times. Control Z, that's an array constant. It's not going to require Control-Shift-Enter, so I'm simply going to use the sum function. And when I hit enter, there is the final score, 3.23 minutes. All right, so 2 function argument array operations. Let's look at example 6. This is an awesome example. Here we have sales teams, and we need to add all of the sales from the sales column for each sales team. Now notice we have a column with sales rep name. Now, one way to solve this is to do this formula. And when I hit F2, that is a long formula. All I did was I did 4 different sum ifs. I did 1 sum if for June, 1 sum if for Sue, and then the 3rd and 4th sum ifs are for Poppy and Tyrone. Now, we can't simply put all of this criteria into 1 sum ifs, because sum ifs would try to find a transaction that had June and Sue and Poppy and Tyrone, and there is no such thing. So simply, we can do sum ifs, lots of them strung together. But there's a much better way. And this is an example where our array formula will help us to create a much smaller formula. We're still going to use some ifs. Sum range, I highlight the sales, Control-Shift down arrow, F4 to lock it because we are copying this to the side, comma, and the criteria range, let's highlight the sales rep, Control-Shift down arrow, F4, comma, and the criteria. Now, normally, if we have many conditions, we have to enter a range and a criteria for each one. But we're going to do a function argument array operation. In criteria 1, I'm simply going to highlight June, Sue, Poppy, and Tyrone. And what this will instruct SUMIFs to do, remember how many items are in that argument? 1, 2, 3, 4. So it will instruct SUMIFs to deliver 4 answers. 1 for June, 1 for Sue, 1 for Poppy, and 1 for Tyrone. This is pretty cool. Close parentheses. And if I F9 to evaluate it, it obeyed us perfectly. I gave the criteria argument 4 different names. And so out pops from SUMIFs 1, 2, 3, 4 different sales totals. That 2490 is for June, 1932 for Sue, and so on. Now we need to add them. Control Z. So we can choose between sum or sum product. But I'm looking at the criteria 1 argument. There's our function argument array operation. And that's not an array constant. That's a range of cells. So if we put it inside of the sum function to add those 4 numbers from SUMIFs, we'd have to use Control-Shift-Enter. Instead, I'm using sum product. We'll simply use the array argument, which can handle that array operation without Control-Shift-Enter, and then let the sum part of sum product add. So I close parentheses at the end, and when I Control-Enter, no curly brackets up there, it calculates perfectly. I drag it over to the side, click in the last cell, F2, and look at that. It got all the cell references correct. Enter. So either much shorter array formula or much longer not array formula. I'm choosing the much shorter array formula. Escape. Now let's go look at our next example, example 7, and this will be another function argument array operation. Now we have an interesting problem at hand. We need to score a Myers-Briggs personality test in the human resource department. So there's 32 questions for this Myers-Briggs test, and every single question gets either A or B. Here's a particular person's responses, and here's the score table. We actually have to look through here and count how many of these the person got and get a score for E. Then we have to come over to the F column and find how many of these items happened over here. Then get a score for F. Now we can see 11B if we go through 11B. That means we would count that one. If I look for 15A, there's a 15A. If I look for 19A, and I can see that person did not answer 19A, so we do not count that one. So in essence, we need to look through each one of these and get a count. Now, instead of doing it manually or some other way, we're going to use the COUNTIFs functions. We're going to say, hey, COUNTIFs, here's your range, and this entire column is your criteria as a function argument array operation. So let's try this. Equal sign COUNTIFs. And now we want to give it all of the possible answers for the letter E as a relative cell reference into criteria range, comma, and then criteria 1. That's going to be our function argument array operation. I'm going to click in the top cell, Control-Shift down arrow, F4. That means in criteria 1, we just gave it 32 items. That means it will instruct COUNTIFs to spit out 32 answers. So when I close parentheses, and by the way, the only possible answers are a count of 1, it found it, or 0, it didn't. So when I F9 to evaluate that, you've got to be kidding me. Look at that. All the zeros mean all the way up to the 6B, which it found, all the way up to the 11b. And so for this particular letter E, 1, 2, 3, 4 will be the score. Control Z, we need to add those. So what are we going to do? Well, this is a function argument array operation without an array constant. So I'm not going to use sum and Control Shift Enter. I'm going to use sum product. The array will handle the array operation without Control Shift Enter, and the sum will add the resultant array. So when I close parentheses, Control Enter, that is the score for E. When I copy it over to the side, all the way to T, hit F2, and there it is. The cell references are working. Now, let's look at one other possibility for scoring this Meyer-Briggs. Now, notice up here, the join column was already created. And actually, look at this. Someone had to create this extra helper column here. And that's perfectly all right. And in fact, it might be preferable. But what if you weren't allowed to have this column? You were just allowed to have question and answer. Could we make that happen? You betcha we could. And I'm going to copy and paste this in edit mode, Control C, and paste it down here, Control V. And notice, criteria 1, we actually, in essence, join these two columns. So we're going to write in our formula, join the question and answer column. So I'm going to click in the top cell, Control Shift down arrow F4. And then right here in our formula, I'm going to use the join operator to join two columns. So now I get my answer, Control Shift down arrow F4. And look at that. That's our first example of using a join operator, not to join a single item to another single item, but we joined a whole column to a whole other column. So if I hit F9, sure enough, you can see we've simulated that whole helper column right in our formula. Control Z, Control Enter, and copy it to the side. If we weren't allowed to have the join column, no problem. We got rid of it. This formula is only looking at the source raw data, in essence, and our scoring table. This one is not going to work because it's dependent on that helper column. Now I'm going to Control Z to leave that there. All right, let's go look at our next example, example 9. Now, our goal here is to calculate the average gross profit for each sales rep. Now, we can't add any extra columns here, so we're going to need to create a single cell solution. Now, here's the problem. First off, we don't have gross profit calculated, so we're going to need in our single cell formula to take each one of the revenues and subtract cost of goods sold to get gross profit. But then we're doing it with, in essence, a condition or criteria. So I really only need gross profit for Jack all the way down. So somehow in my formula, I need to filter out all of the values that don't match the condition or criteria. Now, I would like to use a function like average ifs because we're calculating the average. But we got to go over to our PDFs. And on page 3, here is a list of the sad functions in Excel that can never do array calculations. For example, the lookup value in VLOOKUP, it can never do it. If you tried to do an array calculation in this argument, it just gives you an error. And sure enough, range and average if, and the average ifs criteria range and average range, they will not handle array calculations. Now, I want to notice something about COUNTIFs because we just did a function argument array operation in COUNTIFs, and we did one in SUMIFs. But notice the criteria 1 argument is not listed for SUMIFs or COUNTIFs. Those can do function argument array operations. But these criteria ranges and sum ranges, no matter how hard you try, you're just never going to do it. You get an error message. Now, why they're programmed this way, I don't know. All right, let's go over and see a solution here because we have to calculate average gross profit based on this condition. Well, here's the good news. You can use any aggregate function like average, min, max, and other aggregate functions. And then inside the number argument, we just put the if function. The if function will help us filter out any values that don't match our condition or criteria. So in the logical test argument, we actually have to look at the entire column of all the possible names, F4 to look at, and we have to ask the question, are any of you equal to the condition, in this case, Jack? So are any of you equal to Jack? If I highlight just that little part and hit F9, the answer is a resultant array of trues and falses. You could see that first true means, yeah, it found Jack. All of these falses, it didn't find Jack. That true right there corresponds to that Jack. This resultant array of trues and falses will help filter out all of the values we don't want. Control Z. Now notice that's a comparative operator. That's the first time we've seen a comparative array operation. Now I comma and value of true. Remember, we want gross profit. Well, gross profit is revenue, and I'm highlighting the entire column. Notice it's the same size as all of those trues and falses we got. F4 to lock it. I don't want just revenue, so I subtract the entire cost of goods sold column. F4 to lock it. Now, if we highlight just that part, that is a math array operation. And when I hit F9, there is the entire resultant array of gross profits. Control Z. Now, the magic of the if function right here comes from the fact that we're not going to put anything for false. When we leave false out, anytime there's a false in the logical test, a false value will be substituted in for the number. So watch this. Close parenthesis to leave that false argument out. When I highlight the entire if and hit F9, there are our filtered values. Only the values for gross profit that correspond to Jack show up in our resultant array. Those falses are our filter. And the reason that false will work as a filter is because aggregate functions like average and max and min all are programmed to ignore false. Now, Control Z, that is a bit of if function array formula magic to filter out values we don't want. Close parentheses. Now, that function argument right there, logical test, and the average, all of the functions here, will not handle those array calculations without the special keystroke. Control Shift and Enter. I'm looking up to the formula bar. There's our curly brackets. Double click and send it down. Go to the last cell, F2, and there we go. Now, if we needed to round, we could go ahead and round the value if true, but we're not going to worry about that here. We are just seeing that if we need to make an aggregate calculation with conditions or criteria and there's not a built-in function, we just use the if function inside whatever aggregate function we need. Escape. Now we have two more examples to end out this video. And these are relatively straightforward. This is a special type of function in Excel called an array function. Now, over in our PDFs, there's a list of all the array functions. We're going to look at the transpose function and the frequency function. Now, here's our same example we've been using quite a few times. And as we learned in last video about references and assumption tables, if we have a formula table where the labels are listed vertically, but down in the assumption table, the labels and the numbers we need for our formula are listed horizontally, we can't use mixed cell references. So if we're given a table like this, we want to be able to transpose it. That means I need to take everything in this row and list it in a column, and then list everything in this row in this column. Anytime you want to transpose, you can actually, watch this, copy, and I'm going to come over here, right-click, and there's transpose. Now, this copies and pastes as a transpose. Now, this is a beautiful solution if you don't need to be linked to the original data. If you need to be linked to the original data, you don't copy, paste, special transpose. you use the transpose function. Now, in order to use transpose, you actually have to count. 1, 2, 3. Hey, look at that. There's 4 columns and 2 rows. That means when you come over and highlight the range in advance, you have to highlight 4 rows, 2 columns. Notice that means the items in the columns are going to end up in the rows. Now we have to pre-highlight it because this is an example of an array function that delivers multiple values simultaneously to our highlighted range. Now in the active cell right up here, we type equals transpose. And all we need is the range. Close parentheses. And now, anytime you enter a formula into multiple cells as an array, you have to hold Control-Shift and Enter. And just like that, we have transposed and linked. Now, if this percentage here changes, of course it changes here. And I already did the mixed cell references up here. Everything is linked. Now, our last example is going to be another very useful array function called frequency. Here are some sales values. And oftentimes, we need to count how many of these sales values lie in each one of these categories. Now, notice we're going to count with these upper limits. So for the first category, I need to count everything less than or equal to 250. So that's the upper limit. Then when we get to this category, because I've counted everything less than or equal to 250, the 250 has to be the lower limit, but it's not included. And then we have to have everything less than or equal to 500. In math notation, that means the sales number has to be greater than 250 and less than or equal to 500. Same thing for 750, 1,000. And to make sure that we count everything, we're going to add one extra category here. Even though this is our last upper limit, we're going to add one last category that says, just in case, we're going to count anything greater than our last upper limit. Now, this seems complicated, right? But not when you use the frequency function. This is just the explicit categories that frequency function creates automatically. Now, all you need for frequency is the actual raw data and the upper limits for each category. Here we go. This is an array function, so you have to highlight the actual cells that the answers are going to go into before you create your formula. Now notice I highlighted one more row than there are upper limits. That's because frequency always creates this upper category to catch any accidental values. Now most of the time we're paying attention, so we build enough upper limits to count everything. But they wanted to make this frequency function foolproof, so they always add this extra category. So there it is. You ready? Equals FR, and I'm going to do frequency. Tab. Data array, those are all the values you want to count, comma. And the bins arrays are the upper limits for each category. Remember, we're always going to have one fewer bin array the number of cells we highlighted. Now, we don't need to lock these. And by the way, I didn't even mention that. Transpose, notice we didn't lock any cell references. And the reason why is when I enter this, it gets entered as an array. And we'll actually go look at it. But watch this. Control-Shift and Enter. And instantly it counts all of these numbers within each category. So for example, between greater than 250 and less than or equal to 500, there are 4. And if you go over here and count, you can count them on your fingers. And I sorted it to make it easy. So notice there's the 4. 500 is included in this category because the equal sign is right there. Now, if you go look at each one of these cells here, notice they don't move as the array got entered. Every single time it seems like they're locked, but they're not locked with the F4 key. That's the way an array function works. And in fact, I'm going to scroll back up here. Notice this formula here that we entered, in any particular cell, you can see the array function, and the cell reference is the same in every cell. Now, one other thing about array functions, if I come here and try to delete it with the delete key, Here, it tells us that that is not possible. And the reason why is because that whole block of cells is considered a single unit. It is considered part of the array. It says you cannot change part of the array. The only way you would ever get rid of it is if you actually deleted everything. Now I'm going to Control Z. That's the same down here. And if you did something like try to insert a row, it says no way because it cannot move or mess with that array. Now we mentioned earlier about hard coding array constants. Now here's an example of array constants that were hard coded in as the upper limits. Now normally with a single cell formula we wouldn't have to use Control Shift Enter, but any array formula that's entered into multiple cells as an array has to use Control Shift Enter. All right, that was an amazing video all about array formulas. We saw some built-in array functions, frequency, and transpose. We saw how to do the if function inside of aggregate functions. We saw a number of function argument array operations. This one was calculating a score for Myers-Briggs. We saw this great example where we were trying to add all the sales for each sales team. We saw small function and the large function with an array constant that didn't need Control Shift Enter. We saw how to use sum product to multiply and then add two arrays when they are of the same dimension. We saw how to calculate in a single cell net income, total expenses, and this one total expenses for each month. In each case, we made a math array operation and then housed the array operations or array calculations inside of sum product to avoid Control Shift Enter. All right, that's a lot of fun with array formulas. Next video, we'll actually talk about and or logical tests or criteria in formulas. All right, we'll see you next video.